এরপরে তোমাদের যেটা আসছে যে মেথড অফ আর্ক এক্সটেনশন। সো এটাও তোমাদের খুব ইম্পর্টেন্ট, তোমাদের এক্সামের পারপাসে তোমাদের পরীক্ষায় প্রশ্ন দেয় যে দুটো মেথড অফ আর্ক এক্সটেনশন দাও আর কি। So method of arc extension, these are the two methods of arc extension in circuit breakers. These methods are high resistance method. In this method, the arc is controlled in such a way that is effective resistance increased with time. So the current is reduced to the such a value that heat formed by it is not sufficient to maintain the arc, and thus arc is extinguished. So because of resistive nature of arc discharge, most of the energy in the system will be dissipated within the circuit breaker. This is the main drawback of arc extension. The following are the reasons which can increase the resistance of the arc: and cooling of the arc, increasing the length of the arc, reducing the cross section of arc, splitting of arc. এবার cooling of arc টা কি, being recombination of ionized particles, সেই জন্য হয়। Increasing the length of arc, the length of the arc can be increased by increase the gap length between the contacts. Then reducing the cross section of arc, the cross section of the arc can be reduced by having a small area of contacts on the letting the arc pass through a narrow opening. Then splitting of arc, এটা কি রকম, the resistance of arc can be increased by splitting the arc into a number of small arc in series. Next হচ্ছে low resistance or zero current interruption method. So low resistance or zero current interruption method কি হয়, in an AC system current drops to zero after every half cycle. At every current zero, the arc extinguishes for a brief moment. Now the medium between the contacts contains ion and electrons, so that it has small dielectric strength and can easily break down by rising the contact voltage known as restriking voltage. If such a breakdown occurs, the arc will persist for another half cycle. If immediately after the current zero, the dielectric strength of medium between contacts is built up more rapidly than the voltage across the contacts, the arc fails to restrict the current will be interrupted. The rapid increase of dielectric strength of the medium near current zero can be achieved by cause the ionized particle in the space between contacts to recombine into neutral molecules, and sweeping the ionized particles away and replacing them by ionized particles. The de-ionization of medium can be achieved by in four ways. Around lengthening of the gap length যদি বাড়ানো হয়, then হচ্ছে high pressure, then হচ্ছে by cooling and blast effect. So there are two theories to explain zero current interruption of arc. সো এইগুলো তোমাদের অতটা ইম্পর্টেন্ট নয়, জাস্ট দেখে রাখতে পারো। সেটা হচ্ছে রিকভারি রেট থিওরি অর স্টিফেন্স থিওরি, আর এনার্জি ব্যালেন্স থিওরি অর ক্যাশেস থিওরি। সো রিকভারি রেট থিওরি, স্টিফেন্স থিওরিতে কি আছে, the arc is a column of ionized gases. To extinguish the arc, the electrons and ions are to be removed from the gap immediately after the current reaches to a neutral zero. Ions and electrons can be removed either by recombining them into neutral molecules or sweeping them by away by inserting insulating medium or gas or liquid into the gap. The arc is interrupted if ions are removed from the gap, recovers its dielectric strength, and is compared with the rate at which the restriking voltage or transient voltage across the gap rises. If the dielectric strength increases more rapidly than the restriking voltage, the arc is extinguished. If the restriking voltage rises more rapidly than the dielectric strength, the ionization persists and breakdown of the gap occurs, resulting in arc for another half cycle. So এইখানে তোমার arc extinguisher voltage across a curve দেখানো হয়েছে। So dielectric strength, restriking voltage, dielectric volt. So arc extinguish হলে তোমার dielectric strength এর কার্ভটা restriking voltage এর উপরে থাকে, আর restriking voltage এর কার্ভটা যদি উপরে থাকে dielectric strength থাকে, তাহলে arc কিন্তু extinguish হবে না। So next হচ্ছে energy balance theory or Cash's theory. So the space between the contacts contains some ionized gas immediately after current zero, and hence it has a finite post-zero moment. Power is zero because restricting voltage is zero. When the arc is finally extinguished, the power gain becomes zero. The gap is fully deionized, and its resistance is infinitely high. In between these two limits, first the power increases and reaches the maximum value, and then decreases and finally reaches the zero, as shown in that figure. So due to the rise of restriking voltage and associated current, energy is generated in the space between the contacts. The energy appears in the form of heat. Then the circuit breaker is designed to remove the generated heat as early as possible by cooling the gap, giving a blast air or row of oil at high velocity and pressure. If the rate of removal of heat is faster than the rate of heat of generation, then the arc is extinguished. If the rate of heat generation is more than the rate of heat dissipation, the space breaks down again and resulting an arc for another half cycle. Now related terms associated with arc interruption, এইটা তোমাদের পরীক্ষার জন্য ইম্পর্টেন্ট। রিকভারি ভোল্টেজ, এই জিনিসটা তোমাদের জন্য ইম্পর্টেন্ট। সো রিকভারি ভোল্টেজ হচ্ছে it is normal frequency RMS voltage that appears across the contacts of circuit breaker after final arc extinction. It is approximately equal to the system voltage. So recovery voltage এর তোমার ভ্যালু হচ্ছে ভোল্ট, মানে ইউনিট হচ্ছে কিলো, মানে ভোল্ট বা কিলোভোল্ট। নেক্সট হচ্ছে restriking voltage. It is a transient voltage that appears across the contact at or near current zero during arcing period. At the current zero, a high frequency transient voltage appears across the contact and is caused by the rapid distribution of energy between the magnetic and electric field. This transient voltage is known as restriking voltage. Next হচ্ছে arc voltage. It is a voltage that appears across the contacts of circuit breaker during arcing period. As soon as contacts of circuit breaker separate, an arc is formed. The voltage that appears across the contact during arcing period is called arc voltage. Next হচ্ছে active recovery voltage. It may be defined as the instantaneous recovery voltage at the instant of arc extinction. এখানে তোমার active recovery voltage আর restriking voltage এর একটা ছবি দেখানো হয়েছে। নেক্সট হচ্ছে rate of rise of restriking voltage. এখানে কিন্তু তোমার পরীক্ষায় প্রশ্ন দেয় যে rate of rise of restriking voltage এর ইউনিটটা কি, সেটা হচ্ছে ভোল্টেজের ইউনিট বাই কারেন্টের তোমার টাইমের ইউনিট, মানে ইউজুয়ালি কিলোভোল্ট পার মাইক্রোসেকেন্ড বা কিলোভোল্ট পার মিলি সেকেন্ড, এই ধরনের ইউনিট এর হয় আর কি। আর টাইমটা হাই থাকে, তার সরি ভোল্টেজের ভ্যালুটা হাই থাকে আর টাইমের ভ্যালুটা কম থাকে। সো রেট অফ রাইজ অফ restriking voltage, it is a rate of increase of restriking voltage and is abbreviated by RRRV. Usually the voltage is kilovolt and time in microsecond, kilovolt per microsecond. The value of RRV depends on recovery voltage and natural frequency of oscillation. এইটা হচ্ছে একটা ইকুইভ্যালেন্ট সার্কিট। এখান থেকে তোমাদের একটা ডেরিভেশন দেখানো হয়েছে তোমার RRRV, তো তোমরা ইন্টারেস্টেড থাকলে এটা দেখে নিতে পারো। তোমাদের পরীক্ষার জন্য এটা খুব একটা ইম্পর্টেন্ট নয়, মানে তোমাদের এই ডিপ্লোমা লেভেলে। নেক্সট হচ্ছে rated normal current. So rated normal current of a circuit breaker is the RMS value of current when the circuit breaker shall be able to carry continuously its rated frequency with the rise in temperature and its different paths not exceeding specified values. Values of rated normal current is selected from the standard value of normal uh, hmm, current as per IS 13118, which are 400 ampere, 630 ampere, 800 ampere, 1250 ampere, 1600 ampere, 2000 ampere, 2500 ampere, 3500 ampere, 4000 ampere, 5000 ampere, 6300 ampere. The required high value can be selected. Next হচ্ছে rated breaking current. Rated breaking short circuit breaking current is the highest short circuit current which a circuit breaker will be capable of breaking in a circuit having power frequency recovery voltage corresponding to rated voltage and transient recovery voltage equal to the rated value of circuit breaker as specified in IS. Rated short circuit breaking current is characterized by two values. Number one, RMS value of AC component and its term related to short circuit current, percentage DC component, and standard values of breaking current being 6.3 K, 8 kiloampere, 10 kiloampere, 12.5 kiloampere, 16 kiloampere, 20 kiloampere, 25 kiloampere, 31.5 kiloampere, 40 kiloampere, 50 kiloampere, 63 kiloampere, 80 kiloampere, and 100 kiloampere.